Hi, this is Thomas from AB's Game Tools. In this video we're going to look at how to implement the AI for moving the player around, or the little boy. In the previous video we saw how we could create the context, or scan and populate the context, and in this AI we're going to use part of that information that we just put into the context to choose a position that we can move to. So the first thing to do is to create a new AI. We're going to name this player move 2. We already have, as you can see, we have the list of existing AIs down here. We already have the player AI for moving. We have seen that briefly in previous videos. So we're basically going to recreate that one, and then we're going to look at how it works, and we're also going to look into some alternatives of how you can do things and maybe some flaws in the current implementation. So for our first selector, what we're going to do is we are simply going to have this decide whether or not to actually move or whether or not to just stand still. So in addition to our default qualifier, we're going to add one more qualifier. We're going to add a sum of children so that we can get some scores that will actually do the scoring for us. Now I'm going to call this one has enemies. So this one is going to score out if we have some enemies, and in that case we will want to move on to the next selector. If we don't have any enemies, we're just going to stand still. So I'm going to add a scorer here, which is also called has enemies, and we're giving that a score. Doesn't really matter, as long as the score is higher than the default qualifier, that will suffice. So this means that if the qualifier determines that enemies are within range, that the player can see some enemies, this is going to score 10. Now our default action, we can just call that idle. Oops. Now to implement this exactly as it is in the pre-made AI, we can add an action to that called empty, and also call that idle. If I could spell, there we go. This step is actually not necessary. We have included that in the examples to just accentuate the fact that it actually does nothing. But since the default action actually already does nothing, this is not required, so we can actually just remove it. You can also put it in if you want, if it's clearer for you. It doesn't really matter. It is slightly less performant, but only very, very slightly. So it's really up to you. So now we have our selector with our two qualifiers, and now we need a second selector for this qualifier to connect to, so that we can actually do some movement. So let's go ahead and make another selector. We're just going to choose the highest score wins again. And again we have a default action, and then we need to add some additional actions. Additional qualifiers. Now the first thing we do, we just connect these two, so that if we have any enemies, we're going to move on to here, and we're actually going to do some movement. So let's call this move, and let's call the default action tactical move. So right now when we get here, it will simply always tactical move, but we actually have another option. We would also like to move to power-ups if they are within range. So let's add another qualifier. In this case we're going to choose the all or nothing qualifier. We're going to name this move to power up. And we're going to set a threshold of 100. And now we're going to add some scores. which will decide whether or not we actually want to move to a power-up, or if we're just going to continue on and do our tactical move. So we will base this on two different criteria. One is if we have enemies in range, and the other one is if we have power-ups in range. Now, as you may remember from previous videos, this all or nothing qualifier, it will only score if both of these will score above this threshold. Otherwise, it will return 0. So when we need to decide what score to give these, we should obviously take that into account. Now, the only thing that is actually important in this particular example is that the score is above this. So we can set it to, let's say, 110, and this one as well. Oops, 110. Now the score is irrelevant apart from compared to the threshold, because there are only those two qualifiers. So the only thing that it competes against is the tactical move, which has a score of 1. So basically it just needs a score compared to this one above 1 to score out the highest. But compared to the threshold, we need to put it up above that as well. So for that reason, we put it at 110. So what this means is that now if both of these score out, we will get a score of 220, which is well above 1, obviously, so this one will be chosen. If one of them does not score out, we will have a score of 0, and in that case the tactical move will be selected. So let's just finalize this. The has enemies in range will score out if we have enemies in range. Let's set the range up a bit. So let's set that to range 15. So if we have enemies within a range of 15, this one will score. That is actually not what we want. We want the opposite, because we don't want to move to a power-up if we have enemies within the range that will actually be able to hit us then. So we're going to tick the not, so that just reverses it. So if we do not have enemies within 15 meters, this will score out. So that's what we want. For the next one, do we have power-ups in range? That is what we want to test. And let's just set the range up a little bit so it will go a little further. So if we have that within a range of 8, it will then score out as well. So combined, if we do not have any enemies within a range of 15, but we do have power-ups within a range of 8, then we will move towards that power-up. Or rather, this will score out in that case. The actual movement is not done by the qualifier, but done by the action. So let's add an action next. So for this qualifier, we also need to add an action that actually does the movement. Again, we have already created these actions. We will be looking at the code after we have set up the AI. But as you can see, we have one called move to closest power up, and that matches pretty perfectly with what we are trying to do here. This one on its own doesn't do anything right now, because it needs to actually score the different options given to it. This action will be given a number of scores, a number of power-ups that it can then score to see which one is the best to move to. And we have just one score available for this type of action. It is called power-up proximity to self. This one will score the power-ups according to how close they are to the player, the little boy. So we just give that some score, doesn't really matter. To keep it with default implementation, we're just going to give it a score of 30. So inside of how this works is actually that it will score them inside of a 30 yard range. Obviously the scan is only within 8 yards, but still. So it will look at how far they are from the player, and the closest one will score the highest. They will basically subtract that distance from the player from this score. Well, we'll see that in the implementation a little later. So then we have that set up. I'll move to closest power up, and then we need to look at the tactical move. Now this qualifier is already done, so what we want to do is actually create an action for moving the player. Again, we add an action, and again we have it pre-made, so we have an action called move to best position. Once again, this is what we call an action with options. So it is an action that will be given several options available to move to, and then it will choose whichever best fits the situation that it is in. Now at this point, I think we're just going to move on to the already finished AI, since we have a lot of scores to add to this. And instead of having to see me add stuff, we might as well just switch to it. I have it ready right there. So this is the one we just created, and as you can see, it has quite a few scores, and we're just going to briefly touch on each of them. So remember, it is given, this action is given a number of positions. The sampled positions that we have been filling it, we have been filling these sampled positions into the context, and these sampled positions are then given to this action so that it can choose between these positions and see which one is the best to move to. Let's start from the bottom here. Proximity to player spawner or player spawn point gives a score of 100. This means that the unit will prefer to stay close to where he spawned if nothing else happens. He will try to move towards his spawn point. This ensures that he will return to his original position for where he's positioned fairly central, so that he has the most options to move. Next we have one called overrange to any enemy spawner. In the game we have spawners at different locations where enemies spawn from, and we don't want to move too close to an enemy spawner, because then we can be surprised by enemies popping out, and we will be too close to them, and we will possibly take damage. So this has a pretty high score. Being over range means that it's outside of the range, so anything outside the range of 5 is giving a pretty high score. Over range to any enemy, again it is similar to this. It attempts to keep a distance to enemies. We don't want to get too close to enemies because they hurt. We're going to get into how it's implemented when we look at the code. So line of sight to closest enemy, we want to shoot these enemies, so we also want to prefer to be at positions where we can actually shoot. The same goes for this one. This is just for any enemy. If we have line of sight to an enemy, it is scored higher than if we don't have any line of sight. Then we have proximity to closest power up. This is somewhat related to this up here. It is, as you can see, a fairly low score, but it will give a slight score or better score to cells that are close to power-ups than to cells that are not. So if we have several cells that are equally scored, it will prefer those closer to a power-up. Again, all of these scores combine together into one score. So they all serve a purpose, and together they will then end up giving the best position, matching as many of these as possible. This is the strength of the utility AI. And again, we have an overrange to closest enemy. Similar to this one, any enemy, this is then the closest enemy, because this is the one with the most danger. So we need to make sure that we are not inside the range of the closest enemy, because then he will hurt us. And proximity to nearest enemy can maybe seem a little counterproductive with this one. But we want to, as you can see, the ranges are different. We want to stay out of close range of enemies because then they will hurt, but we also want to stay within a certain range of enemies so that we can actually shoot them. So this one will actually move our little hero so that he has a preferred range of 8 to enemies, to the closest enemy, so that he can actually shoot them. He does have a further range than 8, but still, this makes him move around and he actually hunts down enemies. And then finally we have what we call a tiebreaker. Again, as mentioned, they all combine together. Equal scores, we want a tiebreaker. This tiebreaker is proximity to self. This makes it so that if we have equal score cells, he will choose the one closest to himself, so he doesn't have to move that far. So before we look at the code, let's just see this in action, and then we'll also just look at some of the problems in this before we move to the code. So I'm just going to select the player, because as you have probably seen in previous videos, we already have all these AIs attached, but this one doesn't really exist yet. We haven't made that yet, so we're just going to disable the action. So we only have the scanner that we've created, and we have the move that we've created. So these are now attached to our guy, and we can start the game. And there we have him. So as you can see now, he moves. He doesn't shoot because he doesn't know how to do that yet. But he will now move out of range of his enemies as best as he can. But he's probably gonna die pretty soon. And there we go. No guns, and he's gonna be in trouble. So let's just move back to the AI. Now there is one problem that wasn't really evident in what we just saw, and that is the fact that he actually only acts if he has enemies that he knows of. So if the scanner has put some enemies into his context, he will actually move on to here and do this. But if there are no enemies, if he has shot them all, then he will actually just do his default action, which is to do nothing. Now, this means that if there are power-ups within his range while there are no enemies, then he will not move towards them. This may seem a little bit weird. So we could do something to change that. One way of doing it would be to simply change the default action, which would actually be the best way to do it, because then he would do that if he could, otherwise he still wouldn't do anything. But probably the easiest way right now would be to simply take this move to power up and then simply duplicate it and copy and paste it in here, and then we would have that as a third qualifier in here. But if we do that, we need to change a few things around. Now, this one, as you know, works as a all or nothing qualifier, and it has some scores that it scores out. In this case, it will actually total to 220 if it scores out, but we have our score up here set to 10. So we need to increase this so that it is always highest if it actually scores out. So now that is sorted. So if this one has enemies, he would always go here. If he doesn't, then he will actually see if he can move to a power up, and if he can, then we'll do that. Now then if we look at it, then we will see that this one actually had the scorer. Part of its decision making is if it has enemies in range, but obviously it doesn't, because in this case we already checked that if it has enemies, then it will go here, and obviously if it doesn't have any enemies, then for sure it also does not have any enemies within a range. So we could also just delete this, and then we are just back to having one, so we don't really have to have such an advanced qualifier, or we could simply have implemented this as its own qualifier. But it will still work nonetheless, because as we have an all or nothing qualifier, we still have a threshold of 100, and we still have a test to see if we have power-ups in range. If we do, we get a score of 110, and we will actually move to a power-up. If we don't, we will score 0, in which case it will just go to this one, which has a score of 1, and it will just idle. Okay, so that is a possible improvement, so that he will actually pick up power-ups if he has no enemies in range, but he has power-ups in range. Now finally, before we wrap it up, I'm just going to show you some of the code related to the movement. We are not going to go through each and every one of the different actions and their scores. The survival shooter documentation, the document that accompanies the survival shooter demo, has a full description of each of the different actions and the scores. But I'm just going to give you an idea of how it's created, so you can see how simple it actually is on its own. It is the combination of the actions and their scores that create this emergent behavior or intelligent behavior. So let's look at one of them, the central one, move to best position. So this is the one that will pick from a number of positions, and then it will move to whatever is deemed the best. Now this type of action, as I've mentioned, is called an action with options. In this case is an action with options that are vector 3s. It starts by getting reference to the context. It then scores or finds the best of a number of positions. These positions are represented by the sample positions in the context, and then it simply, unless it is a vector 0 that is returned, it actually moves to this position. So very simple. So how does it get the best one? Well, that's where these scores come in. All the scores attached to it basically decide which one is the best, and the best one will be the one position that has accumulated the highest score from all the scores combined. So let's have a look at how one of these scores look. So let's have this one, proximity to nearest enemy. That's the one I talked about, that it will actually make the unit both retreat and pursue. So again, we have a score. We have a score method, and it gets the context, and then it gets this position that it needs to score. Now the first part, or the bulk of this method, all of this, has to do with actually just finding the nearest enemy. We have all the enemies defined in our context, and then it simply loops through it, and then it defines, picks out the one that is closest to us. Once we have that, we look at the range, and then we return a score, which is the score defined on the scorer, and it has then the range subtracted from the desired range, and that is subtracted from the score. So what this means is that the score is going to be higher the closer the enemy is to our desired range. So this goes both for if we're too close or if we're too far away. Another example is the line of sight. It is, as you can see, the exact same signature of the method. We have a position we need to score, and again we have some enemies that we look through. In this case, this is a line of sight to any enemy, so we look through the list of enemies and we see if these enemies can actually be seen by raycasting and seeing if we hit cover. If we do hit cover, then we do not have line of sight. If we do not hit cover, then in this case we just want to have line of sight to just one enemy. Then it will score. So as you can see, if it finds one that it can see, then it will return the full score. If it has a line of sight to no enemies, then it will return a score of 0, which should have a little F on it. There we go. Okay, so that was it for this video. In the next video, we're going to be looking at how we can implement the action part of the AI so that we can enable our little hero to shoot and throw bombs.